A particular challenge we have in AC power is just the sheer number of equations and variables and components. And so over the next couple slides, we're going to try to summarize all of those. The first thing we really want to deal with is, because we are dealing with signals that oscillate, we are always going to have our voltages represented as some sort of either cosine or sine functions. And we're going to follow the same conventions that we have in phasor analysis, and adopting a cosine reference for each of our functions. And we know that if we're going to move into the phasor domain, then these variables will turn into equivalent polar expressions. And so this would be Vm e to the j phi of v, and then the current function would be the equivalent I m e to the j phi of I. And again, really making sure that this V, and this V are all different things. So Vm is the magnitude of the wave, and our phi here again ends up here. A couple other relationships we might end up with: we reference our signals oftentimes in terms of the magnitude, but we can also reference them in terms of the RMS value. So if you remember, RMS is the magnitude divided by the square root of 2. So Vm divided by square root of 2 is VRMS, in just the same way that Im divided by square root of 2 is IRMS. And so we have our magnitude equivalent representations in the phasor domain, and we can do just the same thing with the RMS values, and said that the RMS phasor value of this object would be VRMS e to the j phi z, and IRMS, and then that is the vector form e to the j phi I. So again, making sure that we know that this value here is the one here. So both I RMS values are the same, and both VRMS values are the same. And we're going to be really, really careful that when we represent phasor values, we ensure that all of our quantities have hats on them to indicate that they are vectors. So going forward, we will really make sure not to have a sleight of hand, because VRMS is not equal to the vector quantity of it, just in the same way that the apparent power is not equal to the complex power. So one challenge in AC analysis is making sure that we get all of our quantities correct when many of them have very similar looking forms.